Every 3 seconds, someone in the world develops dementia. By the time you finish this sentence, 6 more people have crossed that line. Every year, Alzheimer's disease and related dementias affect tens of millions of families worldwide. And yet the conversation most people have about this disease begins far too late, usually at the point of diagnosis, when significant damage has already been done for years, often decades. Here is the part almost nobody tells you clearly enough. The memory loss you are afraid of is not the beginning of Alzheimer's disease. It is the end of a process that started silently, in your brain, without any warning, potentially as far back as your 40s or 50s. By the time the first symptom appears, research shows the underlying pathology has been developing for as long as 25 years. That is what this video is about. Not the symptoms, not the diagnosis, but what is actually happening inside the brain in the years and decades before anyone ever suspects a thing. Because understanding this changes everything about what you should be doing and when. If you want brain health information explained accurately, backed by named research, and presented without exaggeration or invented statistics, reach the families who need this information most. Stay with me through this entire video. What comes at the end? 3 specific things to ask your doctor about is the most practical part. Before we go into the biology, I want to give you one piece of context that frames everything that follows. According to the Alzheimer's Association 2025 Facts and Figures report, more than 7 million Americans currently live with Alzheimer's disease. That number is projected to nearly double by 2050. But here is what the 2024 Lancet Commission, one of the most respected bodies in global dementia research, has concluded. Nearly 45% of dementia cases are potentially preventable by addressing specific, modifiable risk factors. 45%, nearly half. That conclusion only makes sense when you understand what Alzheimer's disease actually is and when it actually begins. Because if the disease starts in your 40s and the window to prevent it is the 2 decades before symptoms appear, then the most important conversation about Alzheimer's is not the one happening in a neurologist's office. It is the one happening right now in this video. Let me start with a brief definition, because many people use the word Alzheimer's without fully understanding what it is biologically. Alzheimer's disease is a progressive neurodegenerative disorder. The word neurodegenerative means that neurons, the brain's nerve cells, gradually deteriorate and die. This is not normal aging. In normal aging, the brain slows slightly. In Alzheimer's disease, neurons die in specific patterns and in significant numbers, starting in the region responsible for forming new memories. That region is called the hippocampus. Think of the hippocampus as the brain's recording studio. Every new experience, every new name, every recent conversation gets recorded there first before being stored elsewhere. When Alzheimer's attacks the hippocampus, the recording studio stops working. New memories can no longer form reliably. Recent events are lost. Old memories, which are stored in different regions, often remain intact for much longer. This is why someone in the early stages of Alzheimer's can remember their wedding day in vivid detail, but cannot remember what they had for breakfast 2 hours ago. The long-term archive is still accessible. The recording studio for new entries is failing. Now let me walk you through exactly how and when this happens, because the timeline is nothing like most people assume. Stage 1, the silent decades. This phase begins as early as 15 to 25 years before any symptom appears. In a landmark study published in the New England Journal of Medicine in 2012, researchers followed families with a rare genetic form of early-onset Alzheimer's. Because they knew in advance who would develop the disease, they could measure what was happening in their brains years before any symptom appeared. What they found was striking. A protein called amyloid, specifically beta amyloid, began accumulating in the brains of participants approximately 25 years before the expected age of symptom onset. 25 years. To understand what this means, you need to understand what amyloid normally does and what goes wrong. Beta amyloid is a protein fragment that the brain produces as a normal byproduct of cellular activity. In a healthy brain, this protein is regularly cleared away, partly through the glymphatic system, the brain's waste removal system that primarily operates during deep sleep. In Alzheimer's disease, this clearance process breaks down. Either the brain produces too much amyloid, clears it too slowly, or both. The excess amyloid begins to clump together between neurons, forming what researchers call plaques. Think of amyloid like rust forming inside a pipe. In the early stages, you cannot see it from the outside. The pipe still carries water perfectly. The outside looks completely normal, but inside, a slow, corrosive process has already begun, and it has been running, undetected, for years. During this entire first stage, the person feels completely fine. There are no memory problems, no confusion, no personality changes. The brain, remarkably, is compensating for the damage already occurring within it. This is the stage where the 2024 Lancet Commission's modifiable risk factors matter most: sleep quality, blood pressure management, physical activity, hearing health. These are the levers that influence how much amyloid accumulates and how efficiently it is cleared. They are most powerful when addressed in midlife, during this silent first stage. Stage 2 begins approximately 10 to 15 years before symptoms, and it represents a second, distinct biological process, one that happens inside the neurons themselves. Every neuron in your brain has an internal transport system, a network of tiny tracks that carry nutrients, proteins, and signals from one end of the cell to the other. These tracks are stabilized by a protein called tau. Think of tau as the railway ties that hold the tracks in place. In a healthy neuron, tau performs this job reliably. In Alzheimer's disease, tau becomes chemically altered. It becomes what researchers call hyperphosphorylated. When this happens, tau can no longer hold the tracks together. It detaches and clumps into twisted bundles called neurofibrillary tangles inside the neuron. The railway ties have collapsed. The tracks fall apart. With the internal transport system destroyed, the neuron can no longer move nutrients to itself, carry signals effectively, or maintain its own structure. It begins to malfunction and eventually to die. If amyloid plaques are the rust forming on the outside of the pipe, tau tangles are the collapse of the pipe's internal framework. The scaffolding that held the pipe structure together from within has started to give way. And crucially, the hippocampus, the memory recording studio we mentioned earlier, is hit first and hardest. Neurons in the hippocampus begin to lose their synaptic connections. Synapses are the junctions between neurons where signals pass from one cell to the next. As these junctions deteriorate, communication between neurons becomes unreliable. Still, during this stage, the brain continues to compensate. It has redundant pathways, alternative routes for the same signals. It is rerouting, working harder to maintain function. The person may notice occasional word-finding difficulties, may feel slightly more tired cognitively, but attributes it to stress, age, or busyness, which is precisely what makes this stage so dangerous. This is the right moment to address the most dangerous misconception about Alzheimer's disease. The myth is this: Alzheimer's is a disease of old age. It is something that happens to people in their 70s and 80s. It is genetic. It is random. It is beyond your control. Every part of that belief is either wrong or incomplete. Alzheimer's disease is not a disease of old age. It is a disease that manifests in old age after spending 20 to 25 years developing silently in middle age. The pathology begins in your 40s and 50s. The symptoms appear in your 70s. The biology does not care what you call the disease. It starts when it starts. And as the 2024 Lancet Commission established, nearly half of all cases involve modifiable risk factors. Risk factors that can be addressed. Risk factors that are within reach. Not after a diagnosis. Now. During the decades when the biology is still building. Stage 3. This is the phase most people associate with Alzheimer's disease, but it is the last phase, not the first. By the time the first recognizable symptoms appear, the hippocampus has typically lost a measurable percentage of its volume. Brain imaging can detect the shrinkage. Neuronal death has reached a threshold the brain can no longer compensate for. The backup routes are exhausted. The rerouting is no longer sufficient. The earliest symptoms of clinical Alzheimer's disease tend to follow a pattern. First, forgetting recently learned information. A conversation from that morning. A name just introduced. Repeating the same question within a short period of time. This is not the occasional tip-of-the-tongue moment that is normal aging. This is a systematic failure to record new information at the hippocampus because the neurons responsible for that recording have been compromised for years. Picture this. You have just had a detailed phone conversation with your daughter. She told you she is coming to visit on Thursday, the time she will arrive, and what she wants to bring for dinner. 30 minutes later, when your spouse asks about the call, you cannot remember the details. Not because you were distracted, but because the recording did not take place the way it used to. Later symptoms, as the disease spreads beyond the hippocampus to affect other brain regions, include difficulty with planning and problem solving, managing finances, following multi-step tasks, tracking appointments, disorientation in familiar places, word-finding problems where the right word simply will not come, and the person may describe objects by their function instead of their name, changes in personality, mood, and judgment. But I want to be clear about something important. These later symptoms are the endpoint, not the starting point, and everything that happens in stage 3 has roots in what began silently in stages 1 and 2. There is one more concept that is critical to understanding why Alzheimer's is so commonly missed in its early phases. Researchers call it cognitive reserve. Cognitive reserve refers to the brain's ability to use alternative neural pathways when primary pathways are damaged. Think of it as having multiple routes to the same destination. When one road is blocked, the brain instinctively takes another. People who spent their lives learning new skills, engaging in complex social environments, reading, problem solving, working in mentally demanding roles. These people tend to have more alternative pathways built into their brain architecture. When Alzheimer's begins damaging neurons, they have more backup routes to fall back on. The symptoms take longer to appear. This sounds like good news, and in one sense it is. Those years of mental engagement provide a kind of insurance. But here is the critical nuance. Cognitive reserve does not slow the underlying biological damage. It does not reduce the amyloid, plaques, or prevent the tau tangles. It simply allows the brain to mask the damage for longer. And when the reserve is finally exhausted, when the backup routes run out, the symptoms often appear more suddenly and at a more advanced stage than they might have in someone with less reserve. This is why some highly educated individuals with significant Alzheimer's pathology can appear cognitively intact for years and then decline rapidly once the reserve is overwhelmed. Cognitive reserve is valuable, but it is not a substitute for addressing the underlying risk factors. It buys time. It does not stop the clock. Here is what the science tells us, summarized clearly. If you are 60 years old and you are watching this video, the amyloid accumulation relevant to your cognitive future may have been building since you were in your 30s or 40s. The tau tangles affecting your hippocampus may have been forming for 10 to 15 years. This is not reason to panic. It is reason to act. Because the 2024 Lancet Commission is equally clear about something else. The same lifestyle factors that drive Alzheimer's pathology can be modified. Sleep quality affects amyloid clearance. Blood pressure management protects the blood vessels feeding the brain. Physical exercise supports hippocampal volume. Hearing health reduces cognitive overload. These interventions do not reverse established damage, but research suggests they can slow the rate of new damage and support the brain's remaining resilience. The window is not behind you. The biology is still responding to the choices you make today. That is what makes this video worth sharing. Here is the most practical part of this video. 3 specific evaluations worth discussing with your doctor, explained in plain language. The first is the MoCA, the Montreal Cognitive Assessment. This is a 10-minute cognitive screening test that can be administered by any general practitioner, nurse practitioner, or specialist. It assesses memory, attention, language, visuospatial skills, and executive function across 30 points. Most people over 60 have never had this test. That is a significant problem because without a baseline score, it is impossible to measure whether your cognitive performance is changing over time. Getting a baseline MoCA at 60 or 65 means that if you return in 2 or 3 years with concerns, your doctor has something to compare against. Ask explicitly, I would like a MoCA test as a baseline cognitive assessment. Can we schedule that? The second is an HbA1c blood test, glycated hemoglobin. This test measures your average blood sugar over the preceding 3 months. It is standard in diabetes screening. But for brain health, its importance goes further. The blood vessels that supply your brain with oxygen and fuel are vulnerable to exactly the same damage as all other blood vessels. And insulin resistance, driven by chronically elevated blood sugar, is one of the most significant threats to that vascular health. Research shows that even pre-diabetic blood sugar levels, above 5.7% on the HbA1c scale, but below the diabetes threshold, are associated with increased risk of cognitive decline. Not because high blood sugar directly destroys neurons, but because it damages the blood vessels supplying them. If you have not had an HbA1c test recently, ask for one. If your result is above 5.7%, that is a meaningful piece of information for your brain health, not just your metabolic health. The third is a conversation about ApoE epsilon 4 genetic screening. ApoE epsilon 4 is a gene variant and the strongest known genetic risk factor for late-onset Alzheimer's disease. Carrying one copy of this variant increases your risk by approximately 3 times compared to non-carriers. Carrying 2 copies increases it by 8 to 12 times. I want to be precise here. Carrying this variant does not guarantee you will develop Alzheimer's disease. Many people with 2 copies never develop it. Many people without the variant do develop it. But knowing your ApoE status can meaningfully inform how aggressively you choose to pursue lifestyle interventions, and it helps your doctors interpret your cognitive health trajectory more accurately. This test is available through many genetic services and some medical centers. Whether to take it is a personal decision that warrants a real conversation with your physician about what you would do with the information and whether knowing serves your well-being. Bring it up. Have the conversation. Here is what to do after this video. 3 actions, 1 for each test. 1. Call your doctor this week and ask specifically for a MoCA baseline assessment. If your practice does not offer it, ask for a referral to a neurologist or geriatrician who does. This is a 10-minute test that could provide years of meaningful baseline data. 2. At your next blood draw or your next scheduled appointment, ask for an HbA1c test if you have not had one in the past 12 months. Note your result and bring it to your next visit. Above 5.7 requires a direct conversation about what you are doing about blood sugar management. 3. Look up ApoE epsilon 4 testing this week. Research what is available in your area. Decide, with your doctor's input, whether knowing your genetic risk status would help you make more informed choices about your brain health. This is a decision, not a recommendation. But it deserves a real conversation. No doctor is going to spend 20 minutes at your next appointment explaining the 25-year biological timeline of Alzheimer's disease. That conversation was never designed into the appointment system. I want to be fully transparent with you. Dr. Mannu Jones is an AI-assisted health educator. This channel does not have a human doctor behind the name. What this channel does have is a commitment to named, verifiable sources every single video. Every claim in this video traces to published, peer-reviewed research. The DIAN study in the New England Journal of Medicine, the biological staging work of Jack and colleagues in the Lancet Neurology, the 2024 Lancet Commission, and the Alzheimer's Association 2025 Facts and Figures Report. The information exists, it is published, it is credible. What has been missing is a clear, honest explanation of what it means for your actual life and what to do with it. That is exactly what this channel is here to provide. One question in the comments before you leave. Has any doctor ever discussed your Alzheimer's risk with you directly? Not in the context of a diagnosis, but as a preventive conversation about your risk and what you can do about it. Yes or no in the comments. I want to understand how many people watching this video have never had that conversation. If this gave you something real to act on, subscribe and share it with one person who needs to hear it. Because the 25-year silent window does not wait for a convenient time.